What's up? This is Madan here, and I'm back with another topic from alcohol, phenol, and ether. And I hope all of you are doing fine. So, what topic I have in the very next section of your NCERT book, if you follow that, it's esterification reaction, right? After you compare the acidity of alcohol, phenol, and water, the very next topic is esterification reaction. So that's what the topic I'm about to explain you. So let's start with that and see how good or bad this is going to be. And I hope this is going to be easy. Why? Because you have to be very confident. Confidence is not something you build up. Confidence is something you need to feel because most of the time we are scared of facing something. And at that moment of time, I feel like a positive thinking can give you the power to overcome a situation like that. So right now, if you have a fear that you have problem with organic chemistry, this is one step towards overcoming that, right? So the topic I have is esterification, right? So let me get that esterification. Now this is something very familiar to most of you. That let me define it first, and then I'll come. The reaction between alcohol or phenol with carboxylic acid or acid chloride or acid anhydride produce a compound with pleasant smell, pleasant and flavored smell called ester. So this is what writing part is. So this is what the theoretical part is, how you can define esterification. But you have to concentrate on the very important part, that it involves basically 4 reactions. Do one by one and try to get it everything. The first one is when you react alcohol or phenol. I hope you understand that this represent to ROH represent to alcohol and AROH represent to phenol. So I'm like writing a general equation, and that will help you to do almost every equation, almost every conversion you need. So when alcohol or phenol react with carboxylic acid, carboxylic acid, RCOOH, right? So when alcohol or phenol react with carboxylic acid, this reaction actually carried out in presence of a little bit of sulfuric acid. So what happened? You just need to understand that carboxylic acid is a stronger. The carboxylic acid is this is a stronger acid. This is stronger acid, and this is a weak acid. This is a weak acid. So an acid is basically a proton donor. So what will happen here? There is a minor mistake I have made. So what will happen here? This will lose the hydrogen. Because stronger acid is proton donor. And this being a weaker acid will accept the proton, right? So this is like coming out to be minus, and this part is plus here. There you have it minus, and this part is going to be plus. This is very important. Let me check you through. This is where you need to concentrate how an organic reaction you can do on your own. You have to understand the mechanism of the reaction. Once you understand, the reaction is going to be real easy, right? So what I explained, almost everything required. Carboxylic acids are stronger than alcohol and phenol. So being stronger, they produce hydrogen ion much easier as compared to alcohol and phenol. So now what you have to do, if this one is a proton donor, this becomes a positive charge, rest of the thing become a negative charge. There, hydroxide group is a negatively charged particle, while the R or Ar is a negatively charged, positively. So what you have to do, take the negative part with the positive one. So R or Ar, and we should write this one first. R, C, double bond, O, and there you have R or Ar, and this is your ester, right? This is your ester. There is another byproduct here, and that byproduct is H plus and OH negative. This is going to be a water molecule. Now this has something to do. You need to understand that we use sulfuric acid here to carry this reaction in presence of. So the function of this sulfuric acid is to dehydrate the water and gives more product, right? So I'm writing this here. We use sulfuric acid so that water as a byproduct can be removed, which keeps the equilibrium in forward direction. That was really very important. I hope you have understand each and every part here, how the reaction taking place, why we are using H2SO4 here, because H2SO4 is a dehydrating agent which helps in eliminating the water, so that we can get more of ester we need. Now the important part is that you can use any alkyl group. There may be methyl here, this may be ethyl, butyl, whatever. Take any alkyl group you need and you will be able to do the equation, right? So that was the first way to prepare the ester. Now let's take you through the other one. Alcohol and phenol react with acid chloride. What this acid chloride is? This is R, C, double bond O, Cl. This is called acid chloride, right? Now this reaction is carried out. You need to understand that this reaction is carried out. Let me remove them. This might confuse you. So this is an acid chloride. What happened here? That acid chloride is a weak acid. However, alcohol and phenol is a strong acid. And this is a weak acid. Now, as I said earlier, the one which is stronger will donate the proton. So what will happen now? This will produce the proton, and then this becomes entirely a negative charge. Similarly, this forms a negative charge and this forms a positive charge, right? So what's coming out to be? You have RCO, R, C, double bond O, and there you have O and R or Ar. There is your ester. But there is a byproduct, and that byproduct is HCl. Now the question is, how you are going to remove this HCl? Now you have to use pyridine. a base. Pyridine is what? A base. So what happened? Pyridine react with this acid and neutralize it, convert it into salt, and this is how it's removed again. So let me write here. This reaction takes place presence of pyridine, a base that neutralize and remove and keep the reaction in and keep the equilibrium in forward direction. So I hope you have understand that when alcohol and phenol react with an acid chloride, this reaction is carried out in presence of a pyridine base, and it produces ester and HCl. But in order to remove the HCl, the pyridine was used. How this works? Pyridine being a base neutralize the HCl, and this is how it is removed, so that more and more product can be produced by keeping the equilibrium in forward direction, right? So this is another method to produce ester. Let me take you through the third one. You know, alcohol or phenol, when react with acid anhydride. So what this acid anhydride is, just take a look. CH3, C, double bond O, O, single bond, double bond O, and CH3. This is called acid anhydride, right? This is really easy. This is really easy. And this reaction is also carried out in presence of acid. This reaction is also carried out in presence of H2SO4. Now try to get through the mechanism of the reaction. What you can do, break any bond between carbon and oxygen. Either break this one or break this one. So let's break this one. So if you break this bond, oxygen will receive the electron. So this become a positive charge, while this entirely become a negative charge. Just pay close attention to what I am doing. This will help you understanding. Don't ignore it. Otherwise, organic is going to be that tough. You might be, feeling from the beginning. So this is negatively charged part of this compound. This is positively charged. Now, acid anhydride. There you have actually. What happened here? This one produces. This is a weak acid here. So now if it's weak, you understand that this will produce OH negative and this will become a positive charge. So positive will go with the negative. Positive will go with the negative. So what I'm going to do right now, CH3, this one, you have C double bond O, there is a single bond O, and then you have R or AR, which is your ester. Now along with that, another product which is going to be, this will come out with a OH. So this will be another alcohol, CH3, C, this will come out to be a carboxylic acid, COOH, right? So this is a carboxylic acid. This is a carboxylic acid, right? So now the question is, what is the function of this sulfuric acid? There it acts as a catalyst. Right? Because there is nothing to remove, and HCl does not remove carboxylic acid because they both are acid. So it acts as a catalyst. So this is how I have described the three methods you can produce ester with. This is really very important. You have to pay very close attention to everything I'm doing, right? So I repeat, when alcohol and phenol react with acid anhydride, it produces ester and carboxylic acid. And how the reaction take place? Since this acid anhydride is a stronger base, this one is a stronger acid, stronger or strong acid. Stronger as compared to this one, not in general sense. All the carboxylic acids, all the organic acids are weak acid, but I am comparing both of it. They both are weak, but as compared to alcohol and phenol, this is stronger. That's what I'm saying. So this being stronger, this will let the bond cleavage in this manner, where you can have option to break the bond between carbon and oxygen right here, or you could also have broken right here. Right? So whatever way you produces a negative and a positive charge, the positive come with the negative and the positive come with the negative. What you have to do is to add them and you get your product there. And what is the function of the sulfuric acid here? It acts as a catalyst to increase the rate of reaction. I will do the next topic in the next video. So I would say thanks for being with me, and in case you like, definitely share what you have to say. The least you could do is to place a thumbs up by liking. That's the least I could expect from you.